So before watching this lecture, you should know about dummy variables and how to handle data that we can categorize into two groups, such as men and women. This lecture is an extension of this to the case when we have data with more than two categories. So the linear regression model where we have data with more than two categories. So this is the method. Let's say that we have three categories to begin with. Let's say, for example, I want to investigate the effect of marital status on salary. So I observe individuals and I note if they are unmarried, married, or divorced. So in general, we have three categories of individuals, and we can call them Group A, Group B, and Group C. It makes no difference which group you assign a specific letter to. So let's just say that Group A are unmarried, Group B are married, and Group C are divorced. So to handle this case with three categories, we actually need two dummy variables. So we introduce these and we call them D1 and D2. I want the I index before the name of the variable. So let's call the observations in group A our base group. And the base group are coded as follows. We code D1 to be 0 and D2 to be 0. The next group, Group B, then we code D1 to be 1 and D2 to be 0. And for Group C, we code D1 to be 0 and D2 to be 1. Note that no observation is coded with a 1 for both dummies. Only one of the dummies, or I should say at most one of the dummies, can be 1. So once I have created these two dummy variables, I can just add them to my regression model. So it will look like this. I have a bunch of ordinary continuous explanatory variables from 2 through k. I add my two dummy variables and I use the parameters gamma1 and gamma2 for these ones. Same kind of analysis that we did for the case when we had only two groups. We see that all individuals in group A, the individuals that are not married, they have both of the dummies equal to 0. So the terms gamma1 di1 and gamma2 di2 will go away, and the intercept for group A, will be beta 1. Similarly, if we look at group B, they have D1 equal to 1 and D2 equal to 0. So their intercept will be beta 1 plus gamma 1. And that allows us then to interpret what this gamma 1 is. It is the extra intercept that group B observations have compared to the base group observations. So in our example, it's the extra salary that a married person will make compared to an unmarried person if the value of all the explanatory variables are the same. Of course, this can be negative as well if married people make less than corresponding unmarried people. And the argument for group C is very similar. They have an intercept that's beta 1 plus gamma 2. So gamma 2 is the extra intercept that group C have compared to the base group. Gamma 2 is the extra income that divorced people make compared to unmarried people when the explanatory variables are the same. Now this idea can be extended to an arbitrary number of categories. So in general, if I have L categories, then I create L minus 1 dummies. Just like we did before, we had 3 categories and we created 2 dummies. I assign one category as the base group, and I set all of the L dummy variables equal to 0 for this group. Then for group B, I set the first dummy equal to 1 and all the other ones to 0. For group C, I set the second dummy to 1 and all the other ones to 0. And so on all the way to group L, in which I set the Lth final dummy variable to 1 and all the other ones to 0. And the interpretation of the parameters follow the same logic. That is, the intercept of my regression model is the intercept for the base group. Gamma 1, the parameter in front of my first dummy, is the extra intercept that group B will have compared to group A. So that really is the increase in the expected value of y for group B compared to group A if all the explanatory variables are the same, that is the x variables. So here is an example. I have the suggested retail price of a bunch of cars. Let's see, we have 251 cars. I have data on which type of car it is. So it can be a coupe. Let's see, we have a hatchback, sedan, SUV, wagon, mini SUV. And yeah, that's it. So we have 8 different categories. And if I want to do regression analysis with 8 categories, we know what to do. We need to create 7 dummies. So here are the 7 dummies. We have to decide on a base group. It makes no difference which one we pick, so let's pick the first one. Coupe is our base group. So all the dummy variables should be 0 for the base group. As a matter of fact, most of the dummy variables will be 0. So if you want to create dummy variables, a good way is to just fill the whole thing with zeros to begin with, like this, and then just add the ones. So we then come to convertibles. That's our second group. So the first dummy should be 1 here, not there, here, like that. This is our group B. Group B, the first dummy is 1. For group C, the second dummy is 1. Our hatchbacks. And then we go to 1 for group D. That's our sedan. Moving on to the SUVs. The minivan, the wagons, and finally the mini SUV. And we will have exactly, for the last group, it should be exactly 1 for the last dummy. That will work out as long as we create 1 fewer dummy variable compared to the number of categories. So now this is the data. This will be our explanatory variables in a linear regression model, and this will be our y variable. We can do this regression in Excel, and in that case, let's use the regress from data analysis, a little bit prettier. So regression, okay, input, let's include the labels, the X data, well, that's now from here, and our Y data, I did the opposite there. So let's do the Y data again. Once I have done the X data, this is one disadvantage of doing econometrics in Excel. You have to have the X variables right next to each other. So let's redo the Y variable like that. Labels, we put it in a new worksheet, call it OLS. Yeah, that should be fine. So if we look at the coefficients, the intercept is for the coupe. Compared to that one, the D1, that's for a convertible. So the convertible cost more than the coupe with similar data for the X variables. But for all the other ones, it's a lower price compared to the coupe. The most significant one is D5. It's a very low p-value, and that's for the minivan. That of course doesn't mean that the minivans are cheaper on average compared to the other ones. It just means that if you have two cars with comparable statistics for weight, horsepower, cylinders, and so on, then if it's a minivan, it's cheaper than if it's a coupe.